Ladies and gentlemen, my name is Paul, and in this Gaming Telecom video we're going to be discussing and analysing CES news from both Nvidia and Intel. Both companies went to stage and released a myriad of different products, and in the case of Nvidia we did not discover the successor to the current GTX 10 series, but what we do have is details on the Xavier SoC, as well as for gamers something very cool, and that is the big format television new standard, which aims to bring low latency for gamers. Intel, meanwhile, were firmly on quantum computing and self-learning. So we have a lot of details concerning new architectures from the company, including a very impressive quantum computing processor. But we'll get to that in a moment. We'll start things out with Nvidia. We're going to start things out with Nvidia's Xavier architecture, which is designed for autonomous vehicles. The chip operates between 20 and 30 watts depending on the performance level that you're looking for, and is built around a 12 nm FinFET process. Perhaps most impressive of all, there are 9 billion transistors which comprise this chip, and Nvidia are touting it to be the most complex SoC ever created.
Without question, this iteration of Xavier is considerably different from what we originally saw debut. For one, the original iteration was built on a 16 nm FinFET process with only 7 billion transistors, so now it's certainly quite the upgrade, and of course is built not just on Volta, but the fact that we have 9 billion transistors on a 12 nm process is nothing short of monumental. So what about the actual specifications? Well, let's start with the CPU side of things first. It does indeed feature a AMR 64-bit architecture, and this in turn means 8 cores with a 10 wide superscalar architecture. Because of the usage scenario which we're going to be seeing within this chip, obviously it's very important that we have error correction, and they've also added functional safety and dual execution as well. Nvidia's Volta architecture is also used for the GPU. This means that we have the ability for FP32, 16 and int16 calculations depending on the environment and the need at the particular time. In terms of performance, we're looking at 1.3 T-flops, and this is peak FP32 performance, and that also is combined with 20 tensor cores. So obviously, because this is for an autonomous vehicle, we also have an ISP on board. No, this is not, of course, so that you can have web surfing on the go. Instead, ISP means image signal processor, which is naturally to process the images of the world around the vehicle. In this particular instance, the chip allows for 1.5 GPIX, which means that we not only have a lot of processing power, but we also have HDR and tile-based rendering. Nvidia are looking to start mass production in late 2018, and eventually they will become part of the Drive Pegasus program. Now, the Drive Pegasus platform, will feature 2 Volta GPUs along with a dual next-generation discrete GPU platform. And if you listen to Nvidia, they are aiming to put out a level 5 driverless robotaxi. In short, you will no longer need to worry about driving the car. You won't need to ever touch the gears, the levers. You pretty much just say the destination and it will do its thing. Indeed, Nvidia have a quote for this: Drive PX Pegasus is powered by 4 high-performance AI processors. It couples 2 of Xavier's system-on-chip processors, featuring an embedded GPU based on the Volta architecture, with 2 next-generation discrete GPUs with hardware created for accelerated deep learning and computer vision algorithms. The system will provide the enormous computational capability for autonomous vehicles in a computer the size of a license plate, drastically reducing power consumption and cost, and Pegasus is designed for ASIL D certification, the industry's highest safety level, for autonomous inputs/outputs including CAN, controller area network, FlexRay, 16 dedicated high-speed sensor inputs for camera, radar, LiDAR and ultrasonics, plus multiple 10 Gbit Ethernet connectors, and its combined memory bandwidth exceeds 1 terabyte per second.
Okay, so now on to big format gaming displays. Certainly one of the niches I'm surprised took so long to fill. Of course, this is primarily a technical reason, but up until recently, you've had one of 2 choices if you're gaming on PC. The first is a smaller display which would have, for example, 144Hz, 120Hz or whatever, but have much higher refresh rates. And of course you could choose between a FreeSync, a Gsync monitor, and life would be grand. The other option would be a much larger display. So for example, you could purchase a 49 or a 65-inch television and, well, it looks great visually. I mean, you could set it up in your living room. The problem is, of course, latency is not ideal. So if you're trying to play something competitive like an FPS, or you're dealing with a game which has a variable refresh rate, then you start to run into some hiccups. And given the sheer abundance now of wireless mouse and keyboard, plus as well, a lot of folks just simply play on controller. Even for example, single player games, you can kind of play FPS on the controller, right? Right? Well, yeah. So Nvidia have decided to tackle this issue with the big format gaming display.
Currently, Nvidia are only showing off the 65-inch variants of this new standard, but obviously this is a new set of display options, and thus I suspect it won't be too long before we start seeing other size variants. Honestly, it's really awesome that we have this technology available. It is a shame that it's of course going to be rather expensive, but these displays offer a fantastic color gamut. We're going to see excellent latency, and quite frankly, the idea of displaying on a large screen 60-65 inches has been the realms of consoles for some time. And obviously has been a really major selling point for consoles, the ability to play on a massive display. And yes, of course, you can, by all means, play on a PC and hook that up via HDMI or what have you. And indeed I do. I play personally on a 49-inch television 4K, and it does pretty well. It's got low latency, it's got game mode and all that stuff, so, the latency isn't too bad. But let's face it, one of the major benefits, one of the awesome factors of playing on a PC is the ability to enjoy 120 Hz or whatever and really get low latency. So while I admit you're going to need a really beefy PC to be able to play 4K with high refresh rates like 120 Hz at 4K, with some games it's just not really going to be doable, but then again the screen is also going to be very expensive, and so will certainly pick up a fan base.
Quantum dot panel, Gsync, 120 Hz, HDR. This television has pretty much every single buzzword that you could cram in to a television. Perhaps more interestingly of all is the fact that they've essentially managed to fit in an entire Shield tablet, which of course means Android gaming is a thing. You can also run Netflix and all that stuff. It's pretty much a hybrid between a monitor and a television, and really straddles the line so much that you can't comfortably call it one or the other. Of course, one can assume it's also not going to be exactly cheap. So if you're thinking you're going to be going down to the store and picking this up for like $350, well, I've got bad news for you.
Also at the Nvidia CES conference, they have updated announced an update for the GeForce related software. Specifically, we're going to see major updates in GeForce Experience and have added Freestyle. This allows real-time visual post-processing effects, up to 15 of them, and you can do this within the game window. While some of them, for example black and white and sepia, depth of field, may look cool, but there is also the ability to enable colorblind mode, which is certainly going to be absolutely fantastic for those gamers who suffer from the impairment. The only negative is that it does require the game to be compatible. And in another piece of news, the GeForce Now cloud gaming service has hit open beta. Originally, we saw this launch on early 2017 for both PCs and Macs, but now it is public open beta. So what this allows you to do is to go to Nvidia and essentially run a server to power your games. You can basically think of it as Netflix, but for gaming. And then you can stream this to either a desktop, PC, a laptop, or finally an Nvidia Shield device. And for those wondering, of course it supports Steam, but also Nvidia have recently added Uplay.
Okay, so now on to Intel. The big elephant in the room, of course, was Meltdown and Spectre, and the CEO did briefly discuss this, but somewhat swept it under the rug, as you would expect. To Intel's credit, though, they did, on Monday, announce the formation of a new group, which is known as the, and I quote, Product Assurance and Security Group, and it aims to essentially prohibit things like this happening in the future. In terms of actual announcements, really most of their product focus was on AI and quantum computing, and there were two products in particular that I found very interesting, so we'll go into those now. The first of these products is going to be known as Loihi, and it is touted as a neuromorphic CPU. So what exactly is a neuromorphic processor? Well, basically it means it can self-learn. Now there is, of course, a lot of marketing gimmick around that, but it does look very impressive.
The Loihi neuromorphic processor will be perfect for AI applications. Obviously, as humans, we have the ability to learn, problem solve, and be able to understand the world around us. The purpose of this particular chip is to essentially mirror that, and it is based on Intel's 14nm process technology. The test chip includes digital circuits which will, at a base level, mimic the brain's basic mechanics. And for the analogy, they have said that it's got 130,000 neurons and 130 million synapses. Once again, that's an analogy, they don't literally have a human brain in there. It has fully asynchronous neuromorphic many-core mesh, which supports a wide range of sparse, hierarchical, and recurrent neural network topologies, with each neuron capable of communicating with thousands of other neurons, and each neuromorphic core includes a learning engine that can be programmed to adapt network parameters during operation, supporting supervised, unsupervised, or reinforcement and other learning paradigms.
Given the fact that it is up to 1,000 times more energy efficient than a typical computing system to accomplish the same tasks, one can argue that this is a very exciting processor. Next up, let's discuss Tango Lake, which is Intel's 49-qubit quantum computing processor. This CPU looks absolutely monstrous, and according to details from the company,
so a couple of months ago, Intel actually unveiled a 17-qubit superconducting test chip. So it's quite the advancement to see the 49-qubit superconducting quantum test chip. For point of reference, the name also has a couple of subtle meanings. The first is it represents a chain of lakes in Alaska, and secondly, of course, quantum entanglement, Tango Lake. We are still very early in the quantum computing realm, and honestly some stuff just still needs to be tested. We don't quite know whether some of the results are actually accurate or not, which is one of the reasons that 49-qubit is so important, because in theory at least it will allow research to assess and approve error correction techniques. After all, there's no point in something creating a result within a fraction of the time of a conventional computer if that result happens to be, well, wrong.
I'm going to read out a quote from Mike Maybury from Intel. He is the corporate vice president and the managing director of their labs. In the quest to deliver a commercially viable quantum computing system, it is anyone's game. We expect it will be 5 to 7 years before the industry gets to tackle engineering scale problems, and it will likely require 1 million or more qubits to achieve commercial relevance. End quote. Regardless, this is a very cool step from Intel, and it will be very interesting to see how the computing world changes over the next several years.
We've been through this piece of news a couple of times over, but Intel have now formally launched the 8th generation core family with the AMD Radeon RX Vega GPU, and of course this is possible because of HBM2 as well as Intel's EMIB technology. We've been through the specifications a couple of times before, but I'll quickly go through it. It is based on Kaby Lake and has 4 cores, 8 threads, all of the CPUs featureless, and as for the clock speed, well, it does depend on the variant. The 8305, for example, has a base clock of 2.8 GHz, whereas the 8809G runs at a base of 3.1, so there's about 300 MHz difference between the different CPUs. The boost clock is really where the story lies, however. The 8305G has a boost of just 3.8 GHz, whereas the 8809G has 4.2 GHz, which is the highest. All of the other chips run at 4.1 with their boost. And as you would expect, the GPU is where the remaining difference lies. So in the case of the RX Vega mobiles, there are 2 different variants, the GL and the GH. The GL has 20 compute units, which means, of course, 1280 shaders, whereas the GH features 24 compute units or 1536 shaders. Naturally, clock speeds are also a deciding factor, so 1011 MHz, which is a bit of an arbitrary number, or 1190 MHz for, once again, the higher end SKU, the GH. Memory is identical between them in terms of amount and bus width, 4GB HBM2, 1024-bit, but clock speeds are a little higher on the GH, which means we have 204.8 GB per second of memory bandwidth compared to 179.2 GB per second of memory bandwidth. And finally, TDP, so 65 watts for the lower end SKUs or 100 watts for the higher end SKUs. And yes, we are kind of skimming over this stuff, but as I said, we've covered it a couple of times in the past, so if you do want to check that out, you can by all means check out those videos which have just popped up over the past couple of days, and I'll try to remember to link them in the video description.
Anyway, with all of that said, hopefully you have enjoyed the video. Now, you're going to notice a format change over the next several weeks, where I do want to be on camera an awful lot more. It won't necessarily be on every video, simply because obviously if it's really late at night, I probably won't have time to set up the camera and all that stuff when news pops up. So in those cases, if it's like emergency news or perhaps a smaller news video, I may not set up the camera, but I do like being in front of the camera. Not just because I find it's better to express myself, but I think it's also more personable. At the end of the day, if I'm frowning, I'm like, you can probably tell I'm not so much happy with the news. On the other hand, if I'm like, it's great, then obviously I'm probably more excited about it. And I think that is much more, I think it opens up a better dialogue between myself and you guys as well, which at the end of the day, that's kind of what this is about, right? There's no point in me putting out content if you don't watch it. It's like, if no one likes it, doesn't get good feedback from it, what's the point of me doing it? And in the end, that's pretty much the reason I do it, because I like the reciprocation. I don't know if that's the best way of putting that, but hey, I just like the reciprocal nature of this, I put something out, someone else comments, hey, have you, thought of this? And it's really good. So I definitely want to start doing that. Anyway, this video has been a bit shorter, simply because, the Intel and Nvidia news hasn't been quite as much of a deluge, I suppose, as what AMD released. I mean, AMD pretty much just opened up the floodgates, and with AMD not releasing a high-end graphics card for the gaming sector, it made a very interesting conference for Nvidia. They didn't really feel that they needed to put out a new card. Anyway, with all of that said, hopefully you have enjoyed the video. Normal stuff, like, share, comment and subscribe. There'll be a lot more content coming on the channel over the next few days, of course. With all of that said, I've been Paul, take care of yourselves, and bye for now.